Let's do a few problems that involve combinations. So let's start with this one. How many 5-card hands are possible? So I'm looking at a deck of cards, and I want to just choose 5 cards. It doesn't matter what order the 5 cards come to me. So this is going to be 52 cards, and I'm going to choose 5 of them. If you want, you can pause the video and practice putting that in your calculator. And what you should get when you put it in the calculator is 2,598,960 hands. So there is 2.5 million ways that you could get 5 cards just dealt to you randomly. Here's the second question. How many ways can you choose 5 face cards? So this time we're not just choosing 5 of any card, we're only choosing from the face cards. So when I pick the group that I'm going to choose from, I want to just talk about face cards. And there are 12 face cards in the deck, and I want to choose 5 of those. So if you'd like, you can pause the video and practice putting this in your calculator. I like to use the option second enter so that the previous problem comes up, and then I only have to retype the numbers. I don't have to keep choosing math probability. But when you try this, you can see that there are 792 ways that you could get 5 face cards. The third problem is a little different, because this time we want to know how many ways we could get 4 aces and 1 other card. So we want both of these things to happen. And this kind of pulls from a little bit of prior knowledge that you should have about probability, and we'll talk about it in another lesson as well. But when you want 2 things to happen, they're either both going to happen or one or the other. And in this case, we're talking about both happening. I want 4 aces and 1 other card. So anytime we're talking about and, that means we have to take our options and multiply those together. So I'm going to start with the 4 aces first. So how many aces are in the deck of cards? 4 of them. And how many do I want to choose? 4. So to get the aces, I have 4 choose 4. And that's something interesting in itself. You should try that on the calculator and see what you get when the number you're choosing from and the number you're choosing are the same. So 4 things, and I want to choose 4. And I want 1 other card. So and I have to multiply this number times this part. So if I chose 4 aces, I've pulled 4 aces out of the deck, there are 48 cards left in the deck. And from those 48 cards, I want to choose 1 of them. So you can try that in your calculator. And what happens is there are 48 ways that can happen. So if you're somebody who plays cards, if you play poker, we saw that there were 2.5 million ways that you could get 5 cards. But notice there's only 48 ways you could get a 4 of a kind. So the probability of you getting a 4 of a kind is not very likely. The last problem has a couple things happening here. We want to know how many ways you could get 3 of one kind and 2 of another kind. So what we're talking about is a full house. I want to get, like, let's say I want to get 3 4s and 2 aces. So 3 of one kind and 2 of another kind. So what I have to do first is narrow it down to kinds. So if you think about the kinds of cards in a deck, all 4 aces would be a kind. All 4 2s would be another kind. All the 3s would be another kind. So when I calculate that, I see that there are 13 kinds of cards. But what I want to do is narrow it down to 1 kind. So I've got 13 kinds, and I want to choose 1 of those kinds. Now from that kind, I want to get 3 out of the 4 cards. So I want to out of the 4 cards, choose 3 of them. So that gives me this first set of cards. I've narrowed it down to a kind, and from those 4 cards, I want 3 of them. But I also want to get 2 of another kind. If I've already chosen one kind here, how many kinds are left? Well, if there's 13 kinds and I already chose one of them, for the second kind of card, I only have 12 to choose from. And I'm going to choose one of them. Now, of that particular kind of cards, there are 4 cards, and this time I only want 2 of the 4. So I'm going to take that times 4, choose 2. So this is quite a string of things that you're going to type in your calculator. And when you do that, you're going to see that you get 3,744 ways. So again, there's only 3,744 ways to get a full house, but there are 2.5 million ways that you can get a 5-card hand. So the probability that you get a full house isn't very likely either.